Hi everybody, I'm back to discuss some concepts based on motion in a plane and laws of motion. Nothing but Newton's laws of motion. Let us enter into this lesson is as follows: oblique projectile, horizontal projectile, projection from top of a tower, motion of projected bodies onto an inclined plane, then laws of motion, in that basically Newton's first law, second law, third law, next connected bodies and contact forces, friction. So these subtopics we are going to discuss in this session. Shall we go? Yeah. Oblique projection. When a body is projected at an angle theta other than 90 degrees and 0 degrees, then that we will call as oblique projection, and the body should move under the influence of gravity. These are all basic fundamentals, basic theoretical concepts. See, between 0 to 90, right? Yeah. And then the acceleration along horizontal direction is 0. When a body is projected obliquely, acceleration along the horizontal direction, along the surface of the earth, is 0. Only acceleration present in vertical direction, that is downwards, and that's value is small g equal to 9.8 meter per second square, right? Yes. Next, for a projectile, for a projectile with respect to a stationary frame which is attached to the earth surface, path or trajectory is parabola, and that equation is equal to y is equal to ax minus bx square, isn't it? Let me write for your convenience. You can recognize it very fastly by writing. That is, the equation is y is equal to ax minus bx square. This is trajectory equation. Of course, y is equal to x tan theta minus half gx square by u square cos square theta. I know the equation. You too should practice. Okay. Yeah. So the thing is, simply speaking, y is equal to ax minus bx square is the trajectory equation, which is a parabola equation. Next, path of a projectile with respect to frame of another projectile is either straight line or maybe anything else. It will be a straight line if and only if the horizontal velocities are matching. Horizontal velocities are matching, then that will become a straight line. Horizontal component of velocity ux is equal to u cos theta. Of course, when a body is projected, you know this u can be resolved into two components. Let me take another color. This u is resolved into two components. This will become u cos theta, u cos theta, u cos theta. This is vertical component, u sin theta. Yeah, sometimes will be in a trance, so should be very careful. Everything I arranged, it's okay, no problem. Red color. This is u. This will be u sin theta, vertical component, and horizontal component is u cos theta. This is u cos theta. Horizontal component u cos theta, vertical component u sin theta. Yes. Velocity of projection magnitude, that is square root of ux square plus uy square, because two vectors are perpendicular, so you can take a resultant like a Pythagoras theorem, square root of ux square plus uy square. And the angle of projection will be tan theta is equal to y value by x value, so tan theta is equal to uy by ux. This is angle of projection, and velocity vector is represented as uxi plus uyj. This is velocity vector. Hope you are with me up to here. Next, velocity after time t. On the trajectory, the particle is at a randomized position based on time. So after time t, the velocity can be calculated like this. That is, horizontal component and vertical component should be calculated separately, and then can be obtained the resultant velocity. Horizontal component remains unchanged. Whenever I try to write, then I'll take the pen until I'll take the pointer. That will be better. Horizontal velocity is u cos theta, vertical velocity is time dependent. Here see, horizontal velocity at any position will be same. That is not going to change because there is no acceleration in horizontal direction. Only vertical velocity component is going to change. vertical component of velocity Vy is equal to u sin theta minus gt, because we are talking about time dependent functions. So Vy is equal to u sin theta minus gt. Now velocity of the particle is v equal to square root of vx square plus vy square. Here I can write, let me take another color. Here this is only nothing but vx is equal to ux. That's what I want to say. Everywhere horizontal velocity will be same, and tan alpha, the direction alpha is equal to tan alpha equal to y value by x value. So tan alpha is equal to, I can write this as alpha is equal to tan inverse vy by vx. That is angle made by the velocity vector with the horizontal. Next, at the highest point velocity is not zero in oblique projectile. Remember, at the highest point velocity not zero, velocity at the highest point is u cos theta, thereby kinetic energy also not zero. At the highest point of the projectile, oblique projectile, yeah, kinetic energy is not zero and velocity is not zero, that is u cos theta. Only vertical component of velocity will become zero, and then velocity and acceleration are perpendicular, you know that. If projected from a level ground, velocity is maximum during projection and during landing, minimum at the highest point. Change in velocity for complete trajectory is 2u sin theta. You see, horizontal velocity remains unchanged. Initial velocity is u sin theta, final velocity minus u sin theta. So difference is 2u sin theta. Yes. Next, velocity of the projectile when it moves perpendicular to its initial velocity is u cot theta. It's an important bit given in so many times in the previous examinations. Velocity of a projectile, I will draw a picture so that you come to know that. Velocity of a projectile when it moves perpendicular to its initial velocity. See, initial velocity vector, let me take another color. Yeah, initial velocity vector is this one. Okay, and is moving in such a way that it's moving like this, and whose velocity vector is perpendicular. If these two are perpendicular, this is u and this is v. Perpendicular, that happens, yeah, you have to observe this condition. Velocity of the projectile when it moves perpendicular to its initial velocity, that is v is equal to u cot theta, and time after which it happens, that is u by g sin theta. After time of u by g sin theta, the velocity vector is perpendicular to the initial velocity vector. Okay, simply on reading the point you may not understand all these, so you have to read the synopsis from the given book to you, and then you have to listen this video sessions. So videos and script both will help you a lot. Of course, slowly listening this by putting pause at some places then will help you a lot. Next, time taken for the velocity to become perpendicular is this one. Yeah, position of the projectile after time t. After time t, where will be it is? That is trajectory equation. Y is equal to x tan theta minus half g x square by u square cos square theta. I know this formula, write 10 times and practice, because you can't derive this in the examination. You have to, because time won't permit. So you have to memorize the final results, and the procedure you have to learn. Next, y is equal to ax minus bx square, where a is tan theta, b equal to g by 2u, blah blah blah, and x is equal to u cos theta into t, horizontal displacement. Vertical displacement is u sin theta into t minus half gt square, and maximum height attained is equal to a square by 4b, range is equal to a by b, okay, range is equal to a by b, and h by r equal to tan theta by 4. That also, okay, I will add later. Next, maximum height attained h is equal to u square sin square theta by 2g, and maximum height attained is maximum when theta equal to 90 degrees, that means vertical throw. Time of ascent is equal to square root of 2h by g, right? Time of ascent equal to square root of 2h by g. Time of ascent, of course time of ascent equal to time of descent, right? In that context this is time of ascent equal to time of descent. In that context it is square root of 2h by g. And time of flight is equal to 2u sin theta by g, that 2 times of square root of 2h by g. And range is equal to ux into 2uy into g. Range is equal to horizontal velocity into time of flight. In that context this formula came. U square sine 2 theta, u square sine 2 theta by g. See, many people get confused with maximum height and range. Maximum height and range are confusing. This is sine square theta. This is sine 2 theta. That the difference, a minute difference you need to understand. U square sine square theta by 2g, u square sine 2 theta by g only. So better you write these two formulae on the paper side by side 5 times and practice, so that these things will help you in the higher classes also. So better you practice. R tan theta equal to 4h, or h by r is equal to tan theta by 4, whatever is easy to you that you can follow. And t is time of flight. Maximum range will come with 45 degrees projection, and that maximum range value is u square by g. Next, you can put pause and you can observe again. Okay, don't feel that sir is going on the slides very fast. You can just put a pause and you can observe those pages, right? Points, right? In terms of range, equation of trajectory y is equal to x tan theta of 1 minus x by r. Or people will write like this: x into 1 minus x by r into tan theta. Some people will write like this. It is somewhat convenient. Next, maximum kinetic energy is half mu square at the starting point of projection, and at the topmost point half mu square cos square theta at the highest point, right? Kinetic energy not zero in oblique projectile, remember. Next, complementary angles of projection. What are complementary angles? Sum of angles 90 degrees is complementary mode, right? Supplementary is 180. Yeah. Here theta and 90 minus theta, complementary angles of projection. H1 is for theta, H2 is for 90 minus theta. Then H1 plus H2 equal to u square by 2g, and r is equal to 4 root H1 H2. These points are very, very important. So many times they ask for these 3 points. And r maximum is equal to 2 into H1 plus H2. And times of flights, they are r is equal to half g t1 t2. Some colon came here, but no problem, you can understand. R is equal to half g t1 t2, t1 t2. So you can have like this here at this place. Okay, yeah. Next, when range is maximum, h maximum is equal to r by 4, because theta equal to 45, tan theta value is 1. So h by r is equal to tan theta by 4. So h maximum is equal to r by 4. Next, r is equal to h maximum if theta equal to, this is important, 76 degrees, then r is equal to h maximum. Next, when a body is projected horizontally from the top of a tower, horizontal projection from a top of a tower, horizontally projected. So you are giving only horizontal velocity, which remains unchanged throughout the motion. You are not giving any vertical velocity to the body. That means initial velocity in vertical direction is 0. That only we are going to discuss here. So initial velocity for the body you are imparting 0 in vertical direction. Horizontal direction you are giving velocity. Then velocity after time t is equal to Vx is equal to u, because whatever you have given horizontal velocity. Vertical velocity will give you gt or root 2 gy, where y is the height of fall. Where y is the height of fall. This is where y is the height of fall. Y is the height of fall. Then vertical velocity component is, let me take this one. Yeah. So Vy is equal to gt or root 2 gy. Net velocity v is equal to square root of vx square plus vy square. Everywhere it is same only, because horizontal velocity and vertical velocity will be perpendicular. So the resultant is equal to vx square plus vy square. Yes. Next, direction of motion or angle made by the velocity vector with the horizontal is alpha is equal to tan inverse vy by vt. Vy can be gt. Here only we wrote gt by u. Yes. Next, velocity on reaching the ground. Velocity on reaching the ground is square root of u square horizontal velocity square plus root 2gh square, that is 2gh. So this is velocity on reaching the ground. Magnitude only this is, not vector form. Next, time of flight t equal to square root of 2h by g. It's like a freely falling body. Horizontal projectile is like a freely falling body. Don't think that horizontal projectile is a different one. It's a freely falling body in case of vertical motion. In case of horizontal motion, constant velocity, uniform motion. Yes. In horizontal direction, no acceleration. So that is uniform motion. In vertical direction, it's a freely falling body. You have to think horizontal motion and vertical motion differently. That's what we want to teach in this chapter actually. Oblique projectile chapter, motion in a plane. Our intention is to teach both are different motions. Horizontal motion, vertical motion are different. You have to treat everything different. You can merge them with the help of time, right? Try to get my point. Next, position of the projectile after time t, two particles, two part. What is this? This we will discuss. Position of the particle after time t. Horizontal displacement after time t. Horizontal displacement after time t. Horizontal displacement after time t is x is equal to ut, of course, and height of fall is equal to y equal to half gt square, correct only. Trajectory is half gx square by u square. This is horizontal projectile points only. If a body is projected horizontally and another is dropped from the same height, both will take the same time to reach the ground. What is that? If a body is projected horizontally and another is dropped from the same height, that means one is freely falling body, one is horizontally projected body. In vertical direction, both should be treated as a freely falling body. So obviously they take same time. Yeah. When an object is dropped from an aeroplane moving horizontally with constant velocity, then path observed by the body on the surface is parabola, and whoever observing from the aeroplane will observe it in a straight line path. Next here, time after which the velocity vectors are perpendicular in this case, in horizontal velocity case, square root of u1 u2 by g. Distance between two bodies when velocity vectors are perpendicular. I will give you a picture so that you can understand it. Suppose this is the horizontal projectile, right? If two bodies are projected horizontally from a, one is with velocity u, one is with velocity u1 and other one with velocity u2, okay? Their velocity vectors are perpendicular. One is with u1, one is with u1, one is with u2. Then their velocity vectors are perpendicular. After a time t is equal to root over u1 u2 by z, and their distance between them, this distance will be square root of blah blah blah. Time after which displacement vectors are perpendicular to root u1 u2 by g. Horizontal distance between two bodies when displacement vectors are perpendicular, horizontal distance. What did he ask? Total distance in the first one. Okay, first one is total distance. This is d point, and one can be here and one can be here, no? So this distance can be the point c. C or b? Yeah, b point. B point is distance. Horizontal distance is d point. That is the difference. Next, projection from top of a tower. So if you project from the top of a tower, yeah, if you project upwards, then u sin theta, you have to take in a different way. If you project downwards, then u sin theta have to take in a different way. That I will tell you. Here, the body's displacement we are taking initially here body, finally it may be here or here or here. So that means h we are taking downwards. This color not good. Let me take another color. Yeah, white will be good. H, oh, here red only, outside, okay. H we are taking downwards, and G we are always downwards only. Then initial velocity u sin theta is vertically upwards in this case. H downwards, G downwards, and u sin theta is also downwards. So whenever all are downwards, you can give for everything same sign. So plus. So this equation will come. In this case, if you give plus for this one and this one, you have to give minus sign for it. So this equation will come. Hope you understand. That is not gt2, that is gt square. Okay, that you know. Not a big task. This is gt square. Okay, yeah. Next, x is equal to u cos theta into t is normal thing, and tan alpha values are so. Next, so main logic I want to give first. Up to the plane, suppose a body is projected. then down to the plane a body is projected. Then equations will be as follows. Time of flight is equal to 2u sin theta by g. Okay, see here, this is the Planck and here is the angle alpha, suppose, and this is g, and this g can be resolved into two components. I will take white color. Yeah, g can be resolved into two components like this and like this. So here along the Planck also will be acceleration, into the Planck also acceleration. This is g cos alpha, adjacent side no cos alpha, this is g sin alpha. So for the two directions, when a body is projected, for this vertical direction acceleration is there, horizontal direction acceleration is there, that is g sin alpha, vertical direction g cos alpha. So wherever you are talking about vertical directions motion like time of flight and height attained, you have to think about vertical acceleration, and whenever you are thinking about displacement x or range, then you have to think about horizontal acceleration. So horizontal acceleration is g sin alpha with appropriate sign plus or minus, and g cos alpha also plus or minus. So time of flight equal to what we have, time of flight equal to 2u by g, but here 2u sin theta minus alpha by g cos alpha, and range r is equal to, actually this motion onto the planes are somewhat important for higher level examinations like BITSAT and JEE mains and advanced and any other AP physics of US systems. These type of things are needed. Range r is equal to u square g cos square alpha of sin 2 theta minus alpha minus sin 2 theta minus alpha. Next, range is maximum for pi by 2, of course. R maximum is equal to u square 1 minus sin alpha. Here I adjusted the place, that's why some letters are on the top line and the bottom line. You can correlate with the printed book whatever you received. R is equal to u square sin u square by g cos square alpha in this case into sin 2 theta plus alpha plus sin of 2 theta plus alpha. Okay, and then R maximum is u square by g cos square alpha. Next, relative motion. Displacement of A with respect to B is, displacement of A with respect to B, x A with respect to B is equal to xa minus xb, like that you have to feel. And velocity of A with respect to B is velocity of A minus velocity of B, and magnitude of relative velocity is square root of VA square plus VB square minus 2 root VA VB cos theta. Actually, if both are in the same direction in a straight line, then you can directly subtract, because cos theta will become 1 and it will become A minus B whole square and it will become A minus B. But if they are at an angle, then you have to use this. Then if objects are moving parallel to each other, VAB is equal to VA minus VB. If objects are moving anti-parallel, VAB equal to VA plus VB. And if objects are moving perpendicular to each other, this is the formula. Yes. Next, Newton's first law. So motion in a plane, those many formulae you have to revise repeatedly and write if possible 5 to 10 times, so that you can do sums fastly. Okay, don't try to derive in the examination, try to learn the formulae and try to learn the derivations while practicing only. Okay, next, Newton's laws. Newton's first law, everybody continues in its state, that you know, until and unless it is acted upon by a net external force. Net external force. And the property of the body is known as inertia, and mass is the measure of inertia. Next, linear momentum. What is linear momentum? Product of mass and velocity is linear momentum. So try to specifically speak, don't say simply momentum, try to speak linear momentum, because we have angular momentum also, right? Yeah. Linear momentum P is equal to mv bar, and change in momentum, that is 2 mv sin theta by 2. If a particle is moving in a circle and moving with constant speed, suppose it has constant speed and it is moving with velocity v, then so change in momentum will be 2 mv sin theta by 2 in this case. Okay, next, a ball of mass m hit at an angle theta to the wall and reflects, hits the wall and reflects, then change in momentum is equal to 2 mv sin theta. Okay, next, the body projected from the ground with velocity u at angle theta to the horizontal, change in momentum will be if a body is projected from ground with velocity u makes an angle theta to the horizontal, then change in momentum will be okay, came as the next point. That is change in momentum will be 2 mu sin theta only for the entire motion. 2 mu sin theta will be entire motion, for entire motion. Okay, for bottom to the topmost point, just mu sin theta, because it is going to become 0 at the topmost point. Yeah, on reaching the maximum height, mu sin theta, and on reaching the ground, 2 mu sin theta. It's already typed, but actually it's a single point typed as 2 points. Okay, next. If the body of mass m is released from height h on reaching the ground, and its momentum is mv, no, so that is root 2gh. Okay, next. Newton's second law. Newton's second law is not F equal to ma. Newton's second law is rate of change of momentum observed in a body, produced in a body, is proportional to the net force applied on it, right? So the rate of change of momentum of a body is directly proportional to the net external force acting on it. Now force definition will come with this, and 1 Newton equal to 10 power 5 dynes, and F is proportional to dp by dt. Proportionality constant we are taking 1, so that SI system is defined like that. Then F is equal to dp by dt. dp by dt means mv by dt. Mass is not constant, mass also variable in case of rocket systems. So that's why m dv by dt plus v dm by dt, which is nothing but uv relation, right? Isn't it? uv of differential rules. So m dv by dt, v dm by dt. And force acting on a body may change direction of motion or magnitude of velocity, or even both. So force may cause any. Next, acceleration is equal to a1 a2 by a1 plus a2 when individually two forces are producing a1 a2 accelerations, and combined force will get a acceleration like this. Next, Newton's third law, everybody knows, that is for every action there is an equal and opposite reaction. Action acts on one body, reaction acts on the another body. That is important. Action, reaction equal in magnitude. Action and reaction acts on different bodies, not on same bodies. That's why centripetal centrifugal forces will not form action reaction pair. So that's what you need to know, because both are acting on the same body. This is one of the reason. Of course, other reason is one is real force and one is fictitious force. Okay. Next, for every action there is an equal and opposite blah blah blah, whatever we discussed. And impulse, in J, impulse is J, that is integral f dt, which is nothing but change in momentum, mv final minus mv initial. Variable mass system formula, anyway we have discussed it now. So force acting for velocity constant, if velocity constant, f equal to dm by dt into v. Okay. Next, for rocket dm by dt into v will be the force. That force should hold the rocket mass and weight, thereby it should give some acceleration. That means whatever the thrust you are getting in upward direction, that should be sufficient to hold its weight and to give acceleration. So mg plus ma, so m can be taken common, so like that m of g plus a comes. If a equal to 0, then just dm by dt into v equal to mg, then it is ready to take off. Okay. Next, water bounces back from the hose pipe, then the force exerted by the water on the hose pipe or on the wall is given by a dv v plus u, where d is density of water and v is velocity, u is bouncing velocity. Those are the terms involved in it. And 2av square d, a is cross sectional area, that I can picturize like this. If liquid is coming from a hose pipe, this is hose pipe, and liquid is coming like this, then here the cross sectional area is a, this is cross sectional area a. How it's coming out, that is cross sectional area a. And then the liquid's density is, of course it is strictly applicable for streamline flows, you know, and density is d. D stands for density. With which velocity it is coming out, that is u, and with which velocity it bounces up, that is v, from the wall. Then force exerted on the hose or force exerted on the wall, both will become action reaction, so both are equal. That's why holding a hose pipe by the fireman is also very difficult, because it takes reverse force. Yes. Next, at an angle, if the water falls I'm talking with water, but for any liquid, for any fluid, you can apply this. That respective density will change. That's it. Okay. If it is water, then you can take water density. If it is any fluid, then D will be changing. If the flow rate of water is increased to n times, then force will become n square times. Here only I can add power will become n cube times. Power will become n cube times, because in the power formula power is equal to F into V, right? Power is equal to F into V. So here proportionality n square, and here one more n. So obviously n cube will come. Anyway, at that place also we'll discuss once again. So if velocity becomes n times, then force will become n square times, power will become n cube times. Yeah, force is nmu when gun is firing n bullets. Next, a pendulum is suspended from the roof of a moving car, then angle made by them, all those things we are going to discuss here. Tension in the string will be m of a square plus e square, tan theta equal to a by g, or a equal to g tan theta, and an object of mass m is kept on a wedge of mass m. The wedge is moving with an acceleration a such that the object moves down like a freely falling body. Then in this case, what kind of things we are going to discuss? Here a equal to g cot theta, a is equal to g cot theta, here a equal to g tan theta. That's the difference you need to understand in this too. An object of mass m is kept on a wedge of capital M. The wedge is moving with an acceleration a such that it is not moving down, then a equal to g cot theta, and theta is here. Okay, connected bodies. Suppose three bodies are connected with two ropes and force F is applied, then system's acceleration is net external force by total mass. Newton's second law, net external force by total mass, that you need to put in your mind. Net external force by total mass, basic, right? Then you will get acceleration equal to net force by total mass. Yeah. Next, tension T1 is equal to mass to be pulled into acceleration. Tensions, I would like to give you a shortcut. What is that? That is, tension is equal to mass to be pulled, mass to be into acceleration. This is my shortcut you can use. So for T1, suppose T1 is equal to mass to be pulled is m1 into acceleration is a, and for T2 mass to be pulled is equal to m1 plus m2 into acceleration a, like that. Okay, yeah, remaining things are easy only, nothing else. Next, suppose in this type of systems acceleration is as usual. What is that? Net force applied is m2g. In this case, net force applied is m2g by total mass is m1 plus m2. That will give you acceleration happily. And tension T is equal to simply m1a you can write, or m2 of this mass is going down. So as this mass is going down, the tension is equal to m of g minus a. If the mass is lifted up, then m of g plus a have to take. Next, yeah, after substituting a value, you will get m1 m2 into g by m1 plus m2. You know 2 m1 m2 by m1 plus m2 into g for which one? Atwood machine. Yes, here one mass is on the table, one mass is suspended. Next, and thrust on the pulleys is root 2t. If the system is like this, then see T3 is equal to m3z. Let me take a pointer so that it will be good for you. T3 equal to m3z, and T2 is equal to m2z plus 3. Similarly, T2 is equal, that means the tension because of the mass and the tension from the other rope, like that we have considered. Or simply you can say T1 is equal to whatever the mass is suspended from that point onwards, m1 plus m2 plus m3, right? T2 is equal to m2 plus m3, T3 is equal to just m3, like that you can m3 into g. Into g only you will get force, right? Tension is nothing but force. Next, a uniform rope of negligible mass. A person suppose trying to climb onto the rope. If the person trying to climb onto the rope, then m of g plus a. If he is sliding down, m of g minus a. Sliding down, m of g minus a. Climbing up, m of g plus a. Okay, yeah, whatever going up m of g plus a, more tension, right? You have to pull the rope, isn't it? Yeah, when two blocks are connected in such a way, first let me get the picture. Yeah, atward mission, right? Yeah, then tension is equal to 2m1 m2 g by m1 plus m2. See, in the examination you won't find to derive. You won't find time to derive. You need to know the formulae. Derivations you have to practice. In tough times, in odd models, you have to derive. In known models and selected models, you need to have the formulae. Acceleration equal to m2 minus m1 by m1 plus m2 into g. And the tension, yeah, we already discussed. Next. And in this case, yeah, net force is equal to m2 minus m1 sin theta into g by m1 plus m2. Remember, sin theta is a component for not mass, for acceleration due to gravity only, that g is taken out. Then next, tension is equal to m2 of g minus a. Whenever block is coming down, you can take g minus a. Next. For this type of system, even though the mass m3 at the middle is not contributing any force for the motion, you have to consider that, because that causes inertia. So acceleration is equal to, even in this case, acceleration is equal to, yeah, applied force is either m1 minus m2 is the net force for the motion, by m1 plus m2 plus m3, total mass you have to consider. Even though that m3 is not contributing any force for the motion, you have to consider total. And equations of motion are as given, constraints they are all. And okay, next, tension is equal to, suppose you are taking tension 2, left side one, tension 2, the body is going up, so g plus a will come. And tension T1, mass is coming downward, so g minus a will come. Okay, that I didn't write here. Huh? Okay, I will write. T2 left side one, that is equal to m2 of g plus a, because it is going up. Okay, and T1 is equal to m1 of g minus a, as it is going down. Whenever the mass is going down, you need to go for g minus a, going up g plus a. And the acceleration of the block a equal to, this is another example. Acceleration is equal to net force applied by total mass. And the force exerted by the rope only on the block is equal to mass to be pulled into acceleration, mp by m plus m, a given model in the previous year exams, many exams. Next, in this case, suppose a big rod or a rope is pulled aside with the help of a force F, then tension at a length x from the force end, that is how much mass to be pulled at L minus x in terms of length. So L minus x, mass to be pulled L minus x into acceleration. What is acceleration? F by L. So like that. Of course, its simplified form is F of 1 minus x by L. Next, contact forces. Contact forces means bodies are in contact and exerting force on one another. Then this type. Here also, acceleration equal to net force applied by total mass only. And this force, whatever the force acted on third one, so that is equal to mass to be pushed into acceleration. I would like to say here, force, contact force F is equal to mass to be pushed into acceleration. So mass to be pushed here, this is equal to m3 into a, and for this is equal to m2 plus m3 into a. That is the fun here. Physics is fun, learning is fun, then only you can learn happily. Next, apparent weight. If you are in a lift, moving lift, then that will be a good example for the apparent weight concept. Okay, of course you can take buoyant force concepts also, but here it is better one. Okay, if the lift is in normal position or moving with uniform velocity, then apparent real weight only it will show. Apparent weight will come whenever the lift is accelerated either upwards or downwards. If it is upward motion, then m of g plus a, downward motion m of g minus a, that concept only. Okay, mg can be taken common to get this. Yeah, this one only you memorize, this one automatically comes. Okay, next, normal reaction force here reads weight. Friction, a tough and big concept. Friction is a tangential force, always opposite to the relative motion, and whenever bodies are in contact and moving, right? It's comes under electrostatic forces, right? Friction also comes under electrostatic force like tension. A body slides and frictions work done always negative because always opposite to the motion. That's why. Static friction, dynamic friction, rolling friction. Rolling friction also a special type of dynamic friction. Static friction whenever body, hey, very important thing. Suppose my students are having their pocket money in my class, and one day I asked them just for fun purpose, will you give 10 rupees? Then the student will give because sir is asking. So of course everybody are like you only. So you will give. Suppose I didn't ask, you won't give. Suppose you gave 200, but I asked 10 rupees, you will give 10 only. Exactly like this. At the time of static friction, what you have to think is whenever two surfaces are in contact, okay, just in contact, there is no friction. Whenever bodies tries to move relative to one another and in contact, then only friction comes to act. Sir came into the class and you won't refuse. Suppose sir forces you to study, then you will refuse. This sir always asking us to study, right? Like that. The thing is, whenever we say to do some task, that means relative motion, whenever comes to act, whenever there is a relative motion, there is a tendency of motion relative to one another, surfaces in contact, then only friction comes to act. Otherwise, no friction. A lorry is on a road, there is no friction between the road and the lorry. If it tries to move or moving, then friction comes to act. Very important point. Next, if it tries to move, it goes to get only static friction. If it is moving, then dynamic friction will come. In that dynamic friction, whether it is a sliding or kinetic friction or the rolling friction, that will be the other task. Okay. Now, maximum static friction will be there. That is, my student is having 200 rupees only. So if I ask 10, he will give 10. If I ask 20, he will give 20. If I ask 80, he will give 80. If I ask 100, he won't give 200. He will give 100 only. So static friction is a self-adjusting force. Static friction is a variable force. Static friction has a maximum value, that is only maximum static friction. That depends upon nature of the two surfaces in contact. Yeah, static friction, the friction present between two surfaces in contact when there is no relative motion between them, that is static friction. When there is a relative motion, that is dynamic friction or kinetic. Rolling, whenever bodies are under rolling. Laws of friction. Limiting friction, that is maximum friction proportional to normal reaction force. More normal reaction force, more friction. Less normal reaction force, less friction. Okay. And quotient of friction do not depend upon either frictional force or normal reaction force. It's a proportionality constant. It depends upon nature of the two materials. That is quotient of friction. Quotient of friction is mu. Kinetic friction is lesser than static friction. And rolling friction is very lesser. You know all those things. Yeah. If I know all those things, why should I listen to your class? Good joke, huh? Yeah. Mu s is greater than mu k. Here is small printing error. This is mu k and greater than mu r. Yes. Next. Laws of friction. Angle made by the resultant of n and limiting friction with the normal reaction n is angle of friction. We will have a picture, I think. Let me check. Here is the picture, then why? So that phi is the angle of friction. How will you get phi? Resultant of normal and friction with the normal is phi. So tan phi is equal to mu automatically. Tan phi is equal to mu. Yeah. Next. Tan phi is equal to mu. Here may I write equal to a. Next. Motion of a body on rough horizontal surfaces. It's a horizontal surface. Rough horizontal surface. Motion of a body. So it is moving. That means kinetic friction is Fk. So applied force is F. Let me take the point. Yeah. Acceleration. Applied force is F. Frictional force is Fk because it's moving. By mass will give you acceleration. See, remember, why are we studying friction also under Newton's laws? Because this is nothing but Newton's second law. Acceleration equal to net force by mass. That's why we are studying this here. Yes? Yeah. So acceleration is equal to applied force minus Fk by m. If suppose the applied force is equal to maximum static friction, then this one will come. This is a special case actually. Mu s minus mu k into g is a special case. If you are applying maximum static friction, then it will move with this much of acceleration. Acceleration obtained when maximum static friction force is applied on the body. Next, if you apply more force, then A equal to F minus Fk by m. Fk is mu mg. Next, and one more thing, normal reaction force means not always mg. Normal reaction force is mg whenever the body is on a horizontal surface. At other times it is going to change. That's why before this slide only we are going to discuss lift concept. In there, normal reaction force is the apparent weight. N is equal to m of g plus a, m of g minus a when it is lifted up and down. So at different places and different situations it will be different. On a horizontal level surface and the body is moving horizontal only and the surface is not moving, then we can take normal reaction force is mg. Next, a block sliding on a rough horizontal surface, that concept only, different things. After what displacement it will be stopped and all those things. That is acceleration equal to mu k into g. So displacement of stoppage or distance traveled before stoppage is u square by 2 mu kg. That is u square, not mu square. Let me change. This is u square. Displacement proportional to initial velocity vector. Yeah, it is like what you call s is equal to u square by 2a. V square minus u square equal to as only. Derivations at this moment I can't discuss much more, just I can give you a hint. Time is equal to u by mu kg, correct. K is a suffix, mu k, k is a suffix. Don't treat it as a bigger letter. Next, a body is pressed against two surfaces, then friction will be on the either sides, here and there. So minimum force needed to prevent from falling is equal to mg by 2 mu s, and mu s is equal to mg by 2f. Body in contact with vertical surface, that concept only, this one. See here, with which force you are pressing the body, that much of normal reaction force will come, and mg is acting down, so tendency of the body is downwards, right? Tendency of motion of the body is downwards, so friction will be upwards. Motion tendency is always opposite direction will be the friction, remember. Next, pile of blocks. Many blocks are there like this. Then how much force is needed to pull one of the block from this? So friction will be here and at the bottom also. Bottom's friction will be more because number of blocks over it are more. Our top ones is less. I can elaborate by taking suppose this is first one, second one, third one, fourth one you are pulling, okay. So for the fourth one, here 3 blocks are there and counting this, the 4 blocks totally. So here also friction will be there and here also friction will be there. This friction related to 3 blocks, this friction related to 4 blocks. So here normal reaction force is 3 mg and here normal reaction force is 4 mg. So that's why these two frictions are not same. So this friction is different, this friction is different. Total friction is 7 mg. Related to that you have to take. That's why n and n minus 1 he took. No problem. Nth one if you are pulling, nth one and n minus 1 you have to take. That is the logic here. Remaining things okay. May I elaborate some further? Okay. N1 is equal to n minus 1 mg, top surface. N2 is equal to n mg. Nth one you are pulling from the top. Right? F is equal to F1 plus F2. That much force you have to give. That simplification is mu into 2n minus 1 into mg. Next, block in a truck. Yeah, whenever truck accelerates, then because of the pseudo force, okay, imaginary force, the block M feels that it is pushed back. It is because of inertia actually, right? So it falls back and falls down. That's why there is a truck rule, legal rule, that is trucks must be packed from the back. That means they must be tied at the back. So open trucks are not allowed on the cities to move. Not only cities, everywhere. Yeah. Pseudo force acts is equal to ma, with which acceleration truck gets, the same acceleration the block will get. So force on it is ma. So applied force on the block is ma. If it is greater than static friction, it slides back. If it is equal to ready to go, if it is lesser, it will be at rest only. Yeah, in that context, we can have acceleration is equal to mu into g, I can say simply. Okay, if that acceleration causes the motion, then net acceleration is equal to a dash is equal to a minus mu kg, because already truck forward acceleration is there. So mu kg is backwards this acceleration. So net acceleration is equal to a minus mu kg, where mu k is kinetic friction. Time of fall is equal to square root of 2l by a dash, that is equal to 2l by a minus mu kg, where a is the truck acceleration and mu kg is frictional acceleration. Yeah, you can think here in this way. On the block, acceleration a is there, friction acceleration is ak is there, so net acceleration is a minus ak, which is a minus mu kg. So this is net acceleration you can take, or relative acceleration, whatever. Next, so distance s is equal to half at square, and time you have already have taken, that you can substitute, you will get the answer. Body in contact with the front surface or accelerating truck. Picture, yeah, this one. Suppose a body is in contact on the front surface. The body usually falls down because of mg. So friction should prevent it. Friction based on normal. Normal is because of the truck's acceleration. If truck is going with acceleration a, it will be pressed against the surface with ma. So that ma is equal to normal. So based on normal, you can get the calculation of friction. Friction is equal to mu n, friction equal to mu n. So mu ma is the friction. That should prevent mg. So that should balance mg. So acceleration minimum equal to a by mu s. Sliding of a chain on a horizontal table. How much maximum length you can suspend? Such type of things will come along with the picture. Where is the picture? No picture. I will give you the picture and I'll explain. Just as a table. Okay, on the table there is a chain. Maximum how much length of the chain can hang? That is the type questions. Maximum length is suppose say L, total length is L. Then here L minus L will be there. Okay. So for better visibility I can take white and yellow, but this is also good. Next. So maximum fractional length of the chain hanging from the wedge on the table is fractional length L by L is equal to mu s by mu s plus 1. Fractional length is small l by capital L, mu s by mu s plus 1. And fractional length of the chain on the table L minus L by L is 1 by mu s plus 1. And maximum length is capital L, what you call before sliding, this small l is the maximum length of the chain. If you exceed this small l value, then it falls down. This is the friction preventable length on the table. That is the logic here. And many times they asked what is L also. L is equal to mu s into L by mu s plus 1. From here onwards you can have. Okay, not a big task. Next. Motion of a body on an inclined plane. Sliding on inclined plane, rough inclined plane, smooth inclined plane, everything will come here. Suppose it's a smooth inclined plane, acceleration is g sin theta along the plank. Acceleration g sin theta. It's important point related. We are going to discuss in even circular motion, rotatory motion, dynamics also. Yeah. And time of descent equal to square root of 2h by g. 2h by g. 2h is length of the plank by g is g sin theta. Like that you can take. And velocity at the bottom is equal to root 2gh, which is nothing but root 2gl sin theta. This is not by, this is L, root 2gl sin theta. Yeah, this is L, root 2gl sin theta. 2gl sin theta. Yeah, next. Body projected up on the smooth inclined plane, smooth inclined plane, then acceleration is minus g sin theta, remaining things as usual will come. Motion of a body down the rough inclined plane, rough, it is a rough inclined plane, then friction automatically will be there. So At one particular angle of inclination only, body starts sliding down. Until that, body won't start. Why? Because friction prevents the motion. So that angle is known as, yes, angle of repose. So angle at which body ready to slide down is angle of repose. We'll call it as alpha. If theta is greater than alpha, then only body comes down. If theta equal to alpha, ready to come, and theta value less than alpha, it remains at rest only. In that case, friction will be applied force only. If it starts sliding down, then frictional force is the mu n formula you have to go. That we will discuss. Yeah, if theta is greater than alpha, the blocks moves downwards, acceleration a is equal to this one. Mg, see, net force is mg sin theta minus mu k mg cos theta. Mg sin theta is applied force, downward force. Mu k mg cos theta is friction, mu n, so friction. Applied force minus frictional force is ma. M on removing, you will get acceleration equal to g of, only formula is better here at this moment. A equal to g of sin theta minus mu k cos theta. Next, velocity before touching the ground is square root of 2gl of sin theta minus mu k cos theta. Length of the plank is L here. And time of descent is equal to t is equal to square root of 2L by g sin theta minus mu k cos theta. If time taken by the body to slide down on smooth inclined plane is what you call, and rough inclined plane, if you are comparing, rough inclined plane's body will take more time. If it is n times of smooth inclined plane, then this is the formula, mu k equal to 1 minus 1 by n square of tan theta. This is the relation between them. Next, body projected up onto a rough inclined plane. At what height it can go, at what displacement it can come up. Those things we are going to discuss. If you are throwing the body onto rough inclined plane, then acceleration will be minus g of, because velocity upwards, opposite, so minus g of sin theta plus mu k cos theta. This is the fun. If the body's tendency is downwards, okay, g sin theta downwards, then frictional acceleration, acceleration due to friction is upwards. If the body is here, body projected upwards, so body's tendency is upwards, body projected up, friction will be back. So here g sin theta is back, g sin theta here, and friction mu ak also here. So both will be added, that's why plus sign. Both are in the same direction, that is important here, okay. Come again, when body is projected upwards, friction backwards, g sin theta backwards, both are in the same direction, that's why plus. That is my intention here. And time taken to stop is 2L by square root of g of sin theta plus mu k cos theta. And this is a good one. Actually, these are all miscellaneous cases of friction. In a trough, an ant is moving or a ball is trying to revolve, so that to what height it can go up. Such things we can discuss here. Minimum force required to move the body up on the inclined plane. This is the previous case only. I think fourth point is this one. Force required to drag the block. Force required to drag the block. This so-called a cup we are going to move in horizontal direction. Then that is equal to F equal to mg sin theta plus mu k cos theta plus ma. Yes. An insect is crawling in a, actually this one also goes to the top block system only. This is different. Here in insect one, this is separate one, this is a separate contest. An insect is crawling in a hemispherical bowl of radius r. H is equal to maximum height to which it can crawl, that is h is equal to r of radius minus radius of 1 minus 1 by square root of mu square plus 1. To that height it can rise. That height is this one. That height is this one. To this height it can rise. That h is equal to r of 1 minus 1 by mu square plus 1. Pushing, pulling. Remember, if you are trying to push or pull at an angle with the horizontal, then only it makes sense and difference. If you are pulling or pushing horizontally, then no use. Both are same only. Okay. A roller on horizontal surface pushed at an angle, then pushed, so one of the component will act downwards and normal reaction force will be increased. N equal to mg plus f sin theta. Yeah. obviously force is equal to mu into mg plus f sin theta. If it is pulled, then mu into mg minus f sin theta will come to act. If it is pulled, that may be a separate one here. Yeah, it is. So normal is equal to mg minus f sin theta. So friction will be lesser. So in this case, friction is lesser because pulling it is. One of the component will act upwards and lifts the body so that contact force decreases, normal decreases, so friction decreases. It's easy to pull. Minimum pulling force. Minimum pulling force is equal to mu mg by cos theta plus mu sin theta. This is minimum pulling force for a block on the surface. Next, phi, this is mu. Okay, so this length is square root of here. One important point I want to tell you: a body is raised onto the surface. That surface is inclined plane. That surface is 1 in 5. He will say like that. 1 in 5 means he is going to say sin theta equal to 1 in 5. That is his sense. Okay, sometimes you are going to know theta he won't give directly, he will give like this. An inclined plank is there whose plank description is 9 in 10. That means sin theta equal to 9 in 10. 1 in 5, 9 in 10, like that they are going to mention. Okay, remember those things. And next, minimum pushing force needed on a horizontal surface. Minimum pushing force. The previous one is maximum minimum pulling force. This is minimum pushing force. For this it is mu mg by cos theta minus mu s sin theta. Previous one is mu mg by cos theta plus mu s sin theta. Okay, yeah, that's the difference for the both. A body is in a drum and is rotated, then how much angular velocity you have to impart to the drum such that it won't fall down. For that, if you are rotating the drum, then there will be a centrifugal force on the block whatever attached to the circumference, that is going to have centrifugal force. That centrifugal force supplies necessary normal contact force and thereby friction. Mg is downwards, friction will be upwards, so that friction balances this mg. So how much? That omega square should be greater than or equal to g by mu sr. Static friction, because it's not, we are not allowing to slide down, so omega square is greater than or equal to g by mu r. Yeah, omega equal to square root of g by mu r. Block on block. If you are applying force on one of the block, the other block also moves due to the frictional force. Frictional force transfers some of the force from the applied one to the next block and tries to carry that also along with it. Friction is due to interlocking of surfaces, that's why. So if the body F is moving forward, then the body, the lower one, in this case especially, the lower block gets friction force backward. Upper block gets a reaction force forward. That's why that also moves forward. I repeat, suppose the lower block you are applying force and here is a small force. So you are applying force like this. So it is trying to move forward. So here for this the friction will be this way for bigger one. And for the smaller one a reaction force will come onto it. A reaction force will come. So it is going to get a force F which is equal to it and opposite to it. Because of it only this small m will move. Okay, m will move with a resultant force F minus F, capital F minus small f, and the formula are as follows. So F maximum is equal to, okay, slowly we can have all the points here, because maximum acceleration of the system without slipping each other actually, that is A into mu g. A into mu g, maximum acceleration, both can have A into mu g, because upper one will get friction only, so that that's acceleration is mu g only. If that only possessed by the lower one also, then it can go with A equal to mu g. Okay, then maximum force needed is, without having a relative motion between the two blocks, mu g into, that is acceleration into mass, small m plus capital M, or upper one plus lower one. That's what. Next, if F is less than, then both will move. If F is greater, then relative motion comes. If F is lesser, then both will move together. If F is greater, then they move separately. Upper one will have only mu kg, lower one will have net force by mass. So simple. Yes, next. Suppose force is applied on the top block. Then the lower one will get a force of frictional force F, which is mu mg, acceleration equal to mu mg by lower mass. Lower mass is m. This is the maximum acceleration that the lower one can get. So if upper one also have the same, then common acceleration will be there, and the force applied maximum is, so this acceleration into m plus m. If you apply lesser force, both will move together. If you apply larger force, then relative motion will come. If it is lesser, both will have a common acceleration, that is mb into a, lower ones into a, and that is f by m plus m. And if you give greater force, then upper one, okay, lower one will get just only mu mg, right? Mu mg by capital M will be acceleration of the lower one. Lower one is equal to mu k mg. This one only, carefully observe. Mu instead of mu s, mu k, because relative motion came. So mu k into mg by m into, and acceleration of the upper block is, net force by mass. Net force is applied force minus frictional force by mass is this one. Next, horizontal circular motion. Horizontal circular motion also we are discussing in this task only. Angular velocity is displacement by time. Displacement is theta. Theta by time is angular velocity. Theta 2 minus theta 1 by. So this is average angular velocity. If the time interval is small, then instantaneous angular velocity will come. And frequency is number of revolutions made per second, right? So this is instantaneous angular velocity. Just like linear motion, angular motion will come. When the particle covers equal angles at equal intervals of time, that is uniform angular velocity. And omega is equal to 2 pi n, where n is frequency, and omega is 2 pi by t, where t is time period. So these two are very important for other things, and this is radians per second. And theta, displacement equal to integral d theta equal to omega into dt. So these things will help you in solving problems. Angular acceleration, same, average angular acceleration, instantaneous angular acceleration, and units are radians per second square. You can put a pause and you can observe, no problem. Next, relation between linear things and angular things. V equal to, actually here we conveniently write r omega, but you try to practice them in such a way. V bar is equal to omega bar cross r bar. So it's actually vectors, all are vectors only here. So V bar is equal to, of course, tensors, vectors, those things I'm not touching here. V bar is equal to omega bar cross r bar. And tangential linear acceleration, AT equal to r alpha. It's not printed, okay, r alpha, yeah. Red color is better for a white background, yeah. For these two, okay. Next, here I think some are missing, okay, they are coming. L is equal to r theta. L equal to r theta. So that's why L bar equal to theta bar cross r bar. Oh, here they wrote r bar cross V bar by r square is omega. Alpha equal to r bar cross AT by r square. And V bar equal to omega bar cross r bar by omega square. Yes. AT equal to this one. And r bar is equal to V bar cross omega. And okay, blah blah blah, everything. Omega bar cross V bar is equal to 0 because they are perpendicular. Cos 90, 0, that's why. And these are also perpendicular. See, one thing I want to say, whenever a body is under revolution or rotation, then angular things are treated along the angle. See, omega will be like this only, alpha will be like this only, angular momentum will be like this only, torque will be like this only, okay, either upwards or downwards based on this right-handed system, and displacement also taken like that only. So tau, L, alpha, omega are like this. So automatically our linear velocity V and AT will be like this. So, and here radial acceleration AR, that will be in this direction. So as per these directions, you can tau, L, alpha, omega all are perpendicular to V and AT. So perpendicular cos 90 0 automatically. Okay, dot products will be 0 for them. Or dot product between these things maximum, because they are in the same direction. In that context, these points will come. Next, kinematic equations in circular motion. Just like linear equations, kinematic equations will come, but only thing is displacement replaced with angular displacement, velocity replaced with angular velocity, and so see, S equal to ut plus half at square becomes theta equal to omega naught t plus half alpha t square. It is alpha, not A, alpha. Let me take red color and write alpha. This is alpha. Yeah. May I write complete equation? Omega naught t plus half alpha t square. Yeah. And this is also alpha t. Alpha t. Omega naught plus alpha t. Alpha is angular acceleration. Omega square minus omega naught square equal to 2 alpha theta. Yes, you are right. Theta equal to 2 pi n. N is number of rotations. Theta is angular displacement. You can have in radians. Oh, still some more is there. Okay. Then I will use other space with another color. Yeah. Angular displacement theta has either simply radians or rotations. If it is rotations, you can use n word. Then theta is equal to 2 pi n. One rotation is 2 pi radians. That's why. Similarly, angular velocity also two ways. One is radians per second. Happily, you can use. This is proper system value only. If n rotations per second, then the story is different. That is n RPS we will call rotations per second. In that case, omega equal to, we are going to take 2 pi n radians per second. This is conversion for rotations per seconds to radians per second. This is the conversion factor. Okay, just multiplication with 2 pi. Reverse also try to understand. Centripetal force or radial force acts towards the center. V square by R is the expression, and R omega square, not W, omega. Okay, R omega square, yes. And AR equal to omega bar cross V bar and omega bar cross omega cross R. Yes. Net acceleration in circular motion. Net acceleration in circular motion. Sometimes in non-uniform circular motion only tangential acceleration exists. Otherwise, tangential acceleration won't exist for uniform circular motion. So, if it is existing non-uniform acceleration, non-uniform circular motion, in that case, AT will be there, AT will be there, AR will be there. This is AT, and circular radial acceleration is, this is AR, and net acceleration is A. So that is equal to square root of AR square plus AT square. Next, motion in a vehicle at turnings, due to centrifugal force it goes off, flies off, right? That's why. Tan theta equal to V square by RG. Theta is the what you call angle of banking. I think let me present the entire thing. Yeah, banked road it is. So maximum velocity which you can maintain is V is equal to maximum square root of RG of tan theta plus mu by 1 minus mu tan theta. This is maximum velocity on a banked road. Maximum velocity on unbanked road, root mu RG. Unbanked road, root mu RG. Banked road, square root of RG of tan theta plus mu by 1 minus mu tan theta. Okay. And frictionless banked road, that is V equal to root mu RG tan theta. Frictionless, no? So V equal to root RG tan theta. Here that also I will write. V is equal to, let me change another color. V is equal to root RG tan theta. This is friction 0. Okay. And here is banking 0. And here is friction is not 0. Banking is also not 0. In that case, this one. Yeah. So these are the things. Let me erase this. So based on this formula, revise formula thrice and twice, and start doing worksheet problems, and I too will do worksheet problems. You can follow. and then later you can do your classwork, what you call practice sheets problems. Ideas, end of the show. Keep on practicing, revise the formula well, and we'll meet in the other session. Bye.